Hello, students. Welcome back to MathsGenii. This is Sanyukta Sharma, and today we're going to talk about the chapter sequence and series. So, before starting the chapter, I'll quickly tell you the difference between what sequence is and what series is. Sequence is nothing but order where the first, second, and the third member is, established. So, a sequence of alphabets A, B, C, D. So, you always know that the first member is A, the second is B. So, this is a sequence. You know that after 1 2 comes, after 2 3 comes, so first second third members of the sequence are ordered, are established. What is series? What is series or progression? They are also sequences, but the sequences which follow a specific pattern. So we are going to explore a lot of series questions in this video. So series, for now, you could remember as something. Series is nothing but a sequence only, but it has repetitions in terms of patterns. Now, there are two types of series, which is finite and infinite. Very simple, very easy to understand with the meaning. Finite is the one which has end. So here you see you have a last term, which is 1024. So this you can say is a finite series. What is an infinite series? If I say that collection of all the even numbers, so it could go on and on and on. So it's an infinite series. Finite as in which has the end, right? Okay, very pretty simple. Then, what are the terms used that you need to know? So, individual elements are called as terms. Individual elements are called as terms. Okay, so in this case, your A1, so the first term, so that is how you denote it. A2, which is your second term, and the last term, this is your last term, so this is going to be AN. So this is how you describe the terms. Okay, now a sequence usually has a rule, as in it will repeat in a specific pattern. Okay, so in the series that you see here, what is the rule? I'll just give you example. Rule for this series would be 2n. So if you insert 1 here, you'll get 2. That's your first element. If you insert in place of n, if you insert 2, you'll get 4. So this is the rule of this series. So series follows a specific rule. That is what this slide is trying to tell you. Pretty simple. Let's see what's in store next. So what is a series? The series of sequence is the sum of the sequence till a certain number. So it is the sum of the sequence till a certain number. I'm just taking the last example again. So it is nothing but sum. It is nothing but the sum of the numbers. Okay, and what is the formula, or how is it denoted? It is denoted as, the plus sign is always denoted as summation. So you have summation k. K starts from 1. So for example, this is your A1 plus A2 plus A3 till an. So k starts with 1. So this subscript you have is k and ends at n. And in the in this would be the rule that we had defined. Remember, 2k. In the last example, I had written 2n. Remember, so the rule. So for this series particularly, what could be written is k is equal to 1 to n for 2k, and then you will get this expansion. So this is how series is denoted. You have learned this in lower standards, but just a little revision. Okay, let's get directly to the sums now. Enough of the revision. So what is the 20th term of the sequence defined by an is equal to dash dash dash? What is the 20th term? So 20th term, which means that n is equal to 20, is what he's trying to tell me. Okay, pretty simple. In place of the question, just put 20 in place of n. Wherever you find n, just substitute it as 20. Okay, so this is going to give you 20 minus 1, 19. This is minus 18, and this is 23. So when you multiply, you will get minus sign. Pretty simple. You had to find 20th term, you substituted it as n. Let's look at some trickier examples now. Now let the sequence be defined as a1 is equal to 1. So in the question, he has given you a1 is 1. And the sequence formula is defined as an is equal to an minus 1 plus 2, where n will start from 2 and n is greater than 2. So whatever value of n you are going to have from this, what I understand is whatever the value of n you are going to have will be greater than or equal to 2, so on and so forth. Okay, now what is he asking? Find the first 5 terms. So first 5 terms, I will put a1 is equal to 1 is already given, so first term I have. Then I will want to find a2. So in place of wherever I have n, I'm going to substitute 2. So 2 minus 1 is 1. And you get it as a1 is 1 plus 2. So a2 is 3. Similar formula for a3. Wherever you have n, you are going to substitute it as 3. Correct? This is the question. This is what is given in the question. So this is a2 plus 2. a2 I have already found out. So it's 3 plus 2, 5. So on and so forth for a4 and a5, you can similarly find out. And it's pretty simple. So I'll just write what you will get. And please solve it and check by yourself. So 1, a1 already given, 3. Then next term is what? 5. Then next term, now I can simply guess, but in exam you will have to solve till a4 and a5 also. Then you have 7 and you have 9. So this was one part of the question. And what is he asking me? Look at the question now. Write the corresponding series. Okay. So what will be the series? What did I explain you? What is series? Series is the sequence of sum. So let's just denote it in the form of sum. This is your series. That is sum. That's it. Okay, so I hope basic concept of series is clear, and now we can just dive in further in details. Okay, so now in your lower standards, I'm sure you have learned AP and GP, which is arithmetic progression and geometric progression. What is the difference in arithmetic progression? You will find a common difference in a sequence. You will find a common difference, and in the geometric progression, you will find a common ratio. We are going to see both in details. Now let's first focus on arithmetic progression. So what you see on the screen is nothing but your first term, second term and third term. This is your general formula. Okay, for example, you wanted to find the 20th term. So in place of n, you will substitute 20 and you will get your answer. Okay, now this formula, this little formula here is the formula of last term. Okay, so we're going to solve examples, don't worry. Then this formula out here is the formula for Sn, which is the total of the entire series, sum of the entire series. So what are the denotions? Let's look at the formula denotion now. A is your first term, L in the formula is the last term, D is the common difference, N is the number of terms, Sn is the sum of those terms. Okay, now for example, you see this. We'll just write what is A, what is the last term, and so on and so forth. So this might be wrong. Okay, we might be having 15 here. So what is the first term? A. What? How do you denote the first term? It's denoted by A. So A is what? 1. Okay. Then let's just forget that we have anything here. Okay, let's just forget this 5. Let's just concentrate till here. Okay, for the sake of understanding. This is not a question from textbook. I've just taken a random example. So A is your first term. What is D? D is the common difference. So can you think and tell me what is the common difference? If you add 2, you will get 3. If you add 2, you will get 5. If you add 2, you will get 7. And 7 plus 2, 9. So what is the common difference in this question? It's 2. Correct? And if I had to find, so using this formula, I had to find the fourth term. So this is your first term, this is your second, this is your third, and this is your fourth term. But I don't know what the fourth term is, but I want to find. So using the formula, I can easily find. The formula was an is equal to a plus n minus 1d. And I want to find fourth term. So in place of n, I will substitute simply the term I want. So I wanted to find fourth term. Then a4 is equal to a, I know it is 1 plus 3 minus 1, 4 minus 1, 3. D, I know it's 2. So 1 plus 6, 7. Is my term 7 right? It's the fourth term, correct? So using this formula, you know how to find the number of term which you want. Similarly, in this example, quickly tell me what is A, what is D? A is the first term. And what is D? D is the common difference. What is the common difference in this question? If you add 3, you will get 11. To 11, if you add 3, you will get 14. To 14, if you add 3, you will get 17. So common difference is 3. So I hope, again, the AP basic concepts are clear. This is all that you need to know. In AP, this slide is all that you need to know. Now let's look at some tougher examples. Okay. So the sum of, so as soon as I see sum, I see AP. I just know one formula. I just go back to that formula. Look at this formula. This is the formula that we are going to use. Okay. This is the first thought that should come to your mind. Secondly, in the question he's telling me there are two arithmetic progressions. Okay, so there will be some arithmetic progression and another. So you have two arithmetic progressions. Okay, so these two are in the ratio of this is to this. So this is to this. Okay, who are in this ratio? Two arithmetic progression. So sum of two, so sum of let's say this is the sum of n terms, sum of n terms in the first AP, okay, upon, let's say this is the sum of n terms in the second AP. Okay, this is clear. So this is what I know, but this is what sum formula I know. What is the sum formula? N by 2, 2a plus n minus 1d. So the n terms remains. So let me just write the formula here somewhere in the corner so that you know what I'm referring to. So the formula is Sn is equal to n by 2, 2a plus n minus 1 d. Okay. So now I'm just substituting n by 2. So the first term of this series will be different. Common difference will be different. So I'm just writing a1 and d1. Similarly, for the second series, the n is going to remain constant because it's given in the question. And then I'm writing a2 and I'm writing d2. Okay, and this as it is. Okay, till now I have just explored the first sentence of the question. Now let's read what is the second sentence of the question. Find the ratio of their 12th terms. Okay, so now what I want to find is the 12th term. So according to the question, I have to find the 12th term ratio. 12th term of first AP upon 12th term of second AP. Okay. I know one formula, correct? For the nth terms, I know one formula. Go back to the formula sheet. What is the formula? An is equal to a plus n minus 1d. Correct? So let's just do a rough calculation here. The formula is an is equal to a plus n minus 1d. I have to find which term? I have to find the 12th term. Okay, so in place of n, I'm just going to substitute 12. A12 is equal to a plus 11d. So the 12th term is a plus 11d. So can I write a1 plus 11d1 upon a2 plus 11d2? This is what I have to find. So the first statement and the second statement of the question have been converted into a mathematical form. Very simple. So now what I can say is, in this question, this will get cancelled, n by 2 will get cancelled. Then if you look at this question very carefully, at this statement very carefully, now I'm going to write it again. So what I want to eventually find out is, I have to convert this equation. I want to convert this into this, because this is what I want to find out, right? This is what is unknown to me. This is what I have to find. So here you have 2a1, but here you have only a1 alone, correct? And here I want 11. But for this, to balance this two, what I'm going to do is, so you will tell me, let's put 12 here in place of n. Let's put 12. So 12 minus 1, you'll get 11d. Right, I will get 11d. But what about this 2? How do I eliminate this 2? So for that, instead of putting 12 minus 1 here, I am going to put 23. So you will see why I'm putting n is equal to 23 in this equation. So 2a1 plus 23 minus 1 is 22d1 upon 2a2 plus 23 minus 1 is 22d2. Again, this side also I'll have to put 23. Okay. Now, let's calculate. This is going to be 77. This is going to be 23 sevens are 167 plus 8, 176. So this is going to be, and I'm going to take 2 common from here. So if I take 2 common from here, what will remain inside is 11, correct? From this, I'm taking 2 common. Similarly, here also I'm taking 2 common. Now this 2 and this 2 will get cancelled, correct? And here I can cancel out this one also. This is divisible by 11. So this is 7 11 sevens are, and this is 11 16s are. If you divide this by 11, you will get 16. So this is what I wanted to find, right? Correct? 12th term. Remember, this is the equation. A1 plus 11d1. A1 plus 11d1 upon A2 plus 11d2. This is what I wanted to find. Therefore, it is very important to smartly understand that why did I put n is equal to 23 in this equation, so that I could eventually take out 2 common and I could get this answer. I hope you have understood. For any doubts, you can always put in the comment section. Okay, let's take up the last example for AP, then we'll go to arithmetic mean. So the income of the person is this in the first year. Okay, so I've got the hint. First year means this is the first term. Okay, first term is denoted by A. Next, he says, and he receives an increase of rupees. So increase, you remember D is nothing but the common difference or the increase. So this is the increase every year, correct? uh, per year for the next 19 years. So your n is how much? And find the total amount he received. Find the total amount he received in how many years? 20 years. What is the total amount that he has been receiving? So n is 20, correct? So the first year is there, and after first year he is working for 19 years, so that will eventually give you 20 only, correct? So now we know only one formula, and he is asking me total. Total means nothing but sum. Total in maths means what? Sum only. So what is the formula? Sn formula I'm applying. So just directly I'm substituting. You can always go back to the formula sheet and refer. I have explained the formula enough. N minus 1, which is 19, and this is going to be, so if you solve this further, it's going to give you 7, 9, 1, 2, 3, 4, and then one more 0 from this 10. Okay, so this is, hence the person received this much total amount in 20 years. You know which formula we used, right? We used the Sn formula. Sn is equal to n by 2, 2a plus n minus 1d. We used this formula for this question. Pretty simple and straightforward question. Okay. Let's move to arithmetic mean. Arithmetic mean, again, you have studied this a lot of time. It's a plus b by 2. So mean, we generally take the sum of all the series upon 2. So we will see with an example. For example, you have to find the arithmetic mean of 4 and 16. Okay. How will you find? 4, so using the formula, this is your A, this is your B. So using the formula, you can say 4 plus 16 upon 2. 4 plus 16 is 20, 20 upon 2 is 10. So arithmetic mean is 10. So now how will this series look like? 4, 10, 6. Okay. Now you've understood mathematically. Now let's go to the theory. Given two numbers A and B, we can insert a number A between them. So this was your A, capital A, and can make it into AP. So this is nothing but in AP only, correct? If you add plus 6, you will get 10. If you add plus 6, you will get 16. So it's in AP, correct? But I have a question. Can we insert two or more numbers between two numbers? So can we if you've been given two numbers, can you insert as many numbers as possible as arithmetic mean to convert it into AP? The answer is yes, of course you can. I'll just give you one more example. So if you have the numbers, say 4 and 16, I can insert say between this number for forming arithmetic mean. I can insert 8, I can also insert 12. Is it forming AP? Of course. If you add plus 4, it has a common difference, correct? So it is forming a AP. So the answer to this question is yes, you can add two or more numbers between two numbers so that the resulting sequence is in AP. Okay, we will quickly look at one example. So he's telling me insert 6 terms between 3 and 24. So I have 3 and 24, and I have to insert 6 terms, which is A1, A2, A3, A4, A5, A6. Okay. Now how do I find these terms? Very simple it is. First thing you need to know is uh, these are the terms, but one mistake that students do is the one that I have done here on the screen. This is the first term, this is your A1, so you have to write it as A2, A3, A4, A5, A6, A7, and this is your term, which is A8. So this I'm keeping on the screen, the mistake to be avoided. Okay, this is the mistake that a lot of students make and the question goes wrong. Okay, so this is my sequence. So a1 is 3. Now treat it as a sequence, and always what do we find? We find a, we find d. A is nothing but the first term, it's 3. D I still don't know, correct? But what I know is that the eighth term, A8, is 24. I know one formula from AP, which is AN is equal to A plus N minus 1D, correct? So I know A8. So in place of N, everywhere I'm going to put 8. A is what? 3. 8 minus 1D. A8 value is 24. 3. 8 minus 1, 7 into D. 24 goes that side, it's become 21. 21 upon 7 gives you 3. So D answer is 3. Correct? So D, you got it as 3. Now you can easily find any of the terms and all of the terms. You have A and you have D, and that is what is needed to find anything. So A2, if for example you wanted to find, just use the formula. Just use this formula that I have used for A8. In place of N, just substitute 2, and D is what? 3. So you will get it as 6. So your second term is 6. Similarly, put 3 here for A3. Put 4 here for A4, 5 for A5, 6 for A6. And that is how you will get the entire series and you will have your answer. And the answer I'm directly giving you because it's just a repetitive step. So the terms is the 3 is given only 3, 9, 12, 15, 18, 21 and 24. So this is what you have to find out. Okay, this is what was given. And what are we using every time? We are using this one formula every time. To find A5, for example, just put 5 in place of N. That's it. So simple. Okay. Now let's go to GP. GP is geometric progression. So the ratio is repeated. So when we will do examples, you will see. So there you had D. Here you have R. Okay. And the general formula you had there was AN is equal to A plus N minus 1D. The general formula you have here is AN is equal to A Rn minus 1. For example, you wanted to find the fifth term. So you will just put in place of N, you will put 5. So N minus 1. So 5 minus 1 is 4. So it's that simple. Then Sn formula for GP, you have it as this. Correct? Now we will do examples so this will get more clear. Okay, let's start with a simple one. This is in GP. How do I know this is in GP? The ratio. So 25 upon 5 will give me 5. 125 upon 25 will also give me 5. So you have a common ratio. Therefore, it is a GP. Correct? So again, same thing. A is the first term. So what is A in this question? A is 5. R is the common ratio. What is R in this question? 5. And now what is he asking me? A10. So I know of a formula. This is the formula. AN is equal to ARN minus 1. AN is equal to ARN minus 1. I have to find A10. So I'll just put 10 here. Okay. A is nothing but 5. R is nothing but 5. N is nothing but 10. Okay. So 5 into 10 minus 1 will give you 9. So 5 raised to 10. This you have 1, right? So 5 raised to 10 is your answer. Okay. That's it. Pretty simple. We've just used one formula in this question. Next question, let's look at one sum example, SN example, and then we will be clear. Okay, find the sum that is SN. Find the sum of 5 terms, that is S5. I want to find out. This much is clear. For every question of GP, you need two things, A and R. A is the first term, which is 1. R is the common ratio. So common ratio, how do you find out? The second term upon the first term. So the common ratio is 2 upon 3. Just to verify, I already got 2 upon 3 as the common ratio, but just to show you how to verify. Then again, I will just check one more time. Second term upon the previous term. So this is nothing but 4 upon 9. Division sign becomes multiplication. So 2 ones are 2 and 3 threes are. So you have 2 upon 3 as the common ratio. Okay. I've already gotten it from the first term itself. So 2 upon 3 is common. S5 you want to find. So I know what is the SN formula. SN formula is SN is equal to A 1 minus R raised to N upon 1 minus R. So in this question, what is A, what is R, and what is N? So I want to find S5, correct? In the question, he has asked me sum of first 5 terms. So N is 5. Okay, what is A? A is 1. What is R? R is 2 upon 3 upon 5. 1 minus 2 upon 3. Okay, let's just solve this and you will have your answer already. Okay, so now anything into 1 is 1 itself. 3 minus 2, 1. 1 upon 3. This upon 3 will go up and become 3, correct? Then you will have 1 minus 2 upon 3 raised to 5, correct? Then you will have 3 into, when you solve this bracket, you will get 211 upon 243. And when you solve this further, when you divide this by 3 ones are 3 eights are, so you'll get 211 upon 81. This is your final answer. In this question, only two things were important: to find what is A, to find what is the common ratio R, and S5 formula. That's it. Okay, now let's move ahead. What is GM? GM is geometric mean. It is given by formula root AB. Okay, now let's look at the question. Very simple. Insert 3 numbers between 1 and 126. Okay, so here you have 1, you have 256. We have to insert 3 numbers. So G1, G2, G3. You can alternatively write it as, it's your wish, you can write it like this also. G4, 256. Okay, why I tell you to write? Because these numbers don't create confusion. Okay, again similarly, in the first AM question you had found A and D. In GM you will find A and R. So what is A? A is the first term. R, ratio I don't know. Ratio I don't know. But I know the 1, 2, 3, 4, fifth term. I know the fifth term, which is A5 is equal to 256. So what is the general formula? AN is equal to ARN minus 1. Correct? AN is equal to ARN minus 1. A5, I want to find out. 5 minus 1, 4. Correct? What is A5? 256. What is A? 1. R raised to 4. Anything raised to 1 is 1. Anything raised to 1 is that number itself. 256. Let me just write 256 as something else. Okay, if you know what 256 is, 4 raised to 4. So you will have r, so this 4 and this 4 gets cancelled out, and you will have r is equal to 4. Okay, but when you take square root, remember, you get two answers, plus and minus. Similarly, you will here also get two answers, which is plus 4 and minus 4. So you have 2r. You have r ka value 2. So you have r as plus 4 also, and you have r as minus 4 also. Correct? Now let's find it out. Now I want to find G2. How do I find G2? The same formula. I want to in place of n, I'm going to substitute 2. So you will have a as 1, r as, if you have 4, then you will have this G2. This is one value of G2, but you have two r's. So again, in place of this r, you are going to put minus 4. So your answer is going to be minus 4. Similarly, G3 and G4 you find out. What I want to try to tell you here is you are going to have two series. One where you are going to substitute 4, and other where you're going to substitute minus 4. Let me solve one more for you. If I have to find G3, then the formula is what? An is equal to a rn minus 1. So I want to find third term. So a is 1 given in the question, r is plus 4, and 3 minus 1. So you will get 4 into, so 16. But you have one more r. So you will have it as minus 4, 3 minus 1. So minus 4 square. Square of negative term is always positive. So for in this case, you will have 16, 16 as the same answer. But for the second term, here you had 4 and here you had minus 4. So let me just tell you how the final answer is going to look like. This was your question, correct? So your final answer will have two series. One, 256, you had to enter three terms here. 4 I found out, 16 I found out. The last term, which you can solve all by yourself, last term is going to be 64. Okay, for the sake of avoiding confusion, I'm adding comma. And for minus 4, again you have 256. You had to insert three terms, minus 4, 16, and minus 64. So G1, G2, G3. This is how you found it out. Okay, I hope this is clear. Let's move ahead to the next concept. Special sequences. Okay, in lower standards, you must have studied sequence for 1 plus 2 plus 3 till n, and you must have studied this formula, n is equal to n plus 1 upon 2. This is some ninth grade, I think. Okay, now we are going to upgrade. You had learned this, but we are going to derive this. We have just added square here. Okay, so we are going to find the formula for this using the derivation. Okay, so stick with me. The derivation could be long, but I'll just try and explain each and every step to make it shorter. Okay, so this is what we want to derive. Then what I'm going to assume is I'm going to take one polynomial. Okay, let this be some polynomial. Okay, now for this formula, for this I know a formula, a plus b the whole cube, which is a plus b, and then the normal formula, a square plus 2ab plus b square. So I've just expanded this. Then if you further expand and multiply inside the brackets, you will get the final output as this. Okay, this will also get multiplied and you'll get the final output as this. Okay, I hope everyone is clear till this point. Okay, Now, this sequence, whatever the sequence will be, it is going to start with 1 and end at n. So it is going to start with 1 and end at n. Okay, this I know. This is the range. Correct? Now, in this golden statement, this beautiful statement that I've found out, I'm just going to substitute values from 1 till n. Okay, pay careful attention. So, in place of x, wherever you have x, I will be putting values from 1 to n. So, you have 1 here. Okay. Then you have 2 here. So on and so forth till n, correct? X plus 1. Okay, here then you will put 3, 4, 5, 6, and so on. Let me just put n here because n is the last value in this equation. So in place of x, I'm just putting n. Okay, I have this ready. Now look at this step. If we add up each separately, so what we are going to do is we are going to add this. We are going to add all of this separately. Now you will have to stay with me with full attention. Okay, if you add this up, 1 plus 1 2, so you'll get 2 cube. 2 plus 1 3, so 3 cube, plus this n plus 1 cube equal to, then I'm adding this row. Okay, this column I'm adding 1 cube plus 2 cube plus n cube. Okay, now I am adding this column. So 3 is common for all, so I'm taking 3 common. Then you have 1 square, 2 square till n square. Okay, then I'm adding this column. You have 3 common, then you have 1 plus 2 plus 3 till n. Then I'm adding this column. For this you have 1 plus 1 plus 1 plus 1 plus 1. Okay, plus till 1. Okay, you have 1 all along. So what I have done here, I've done nothing. I've just added my substitution together. Okay, this is the main step of the entire theorem. Okay, now pay careful attention. 2 cube, 2 cube will get cancelled. Here you will have some 3 cube that is going to get cancelled. So all this is going to get cancelled. Okay, what will remain this side is only this term. So you will be left with n plus 1 the whole cube and an equal to sign. Okay, this all has gotten cancelled already. Now what will remain is this 1 cube. So it's 1 plus 3 into 1 square plus 2 square plus n square. This is what I want to find, correct? See, we had started with that. This is what I wanted to find, 1 square plus 2 square till n square. So this is what I want to find. Okay, plus 3 into. Now look at this very carefully. Okay, I'm just star marking this. This is what you had studied in 9th standard. For a series which starts with 1 and ends till n, the general formula is n into n plus 1 upon 2. So I'm just writing in place of this entire terms, I'm writing n plus 1 upon 2. Plus, you have n till the end. You have 1 plus 1 plus 1. How many times? I don't know. It can go till n times. So in place of this, I'm writing n. So this is very important to understand. In place of what, I'm writing what. Okay. Now let's go ahead. This means that this is what I want to find, right? This is what I want to find. So let's just keep this on this side. Okay, and let's just bring all the other terms on this side. This plus comes this side, becomes minus. Then this plus n becomes minus n. This plus 1 becomes minus 1. Okay, and then on this side, what are you left with? Your this term, 3 into 1 square plus 2 square till n square. Okay, this is what you are left with. Now what am I going to do next? This implies that this 2 is going, I'm just giving this 2 to everyone. Okay, this 2 will go to everyone, so this will become, this 2 will go here, so 3 2s are 6, so this will become this. Okay, then this will, when you simplify, open all the brackets, so it will go very lengthy on the board, so you just have to open this brackets, everything else is done already. So 2n cube plus 3n square plus n, so you will be left with this. So this is what I want to find, 1 square plus 2 square till n square. So 6 is of no use, so let's bring it here. 2n cube 3n square plus n upon 6. Okay, again this I'm just writing it as s for now. Okay, and again if you further simplify this using your binomial theorem, you will get the formula n is equal to n plus 1 2n plus 1 upon 6. You can check, you can expand this and you can check. So n into n will give you n square plus n, so you have here plus n. So you can check anytime you want, you can open all three brackets and you will get the same term. So this derivation was very lengthy, but if you have followed every step, it's very simple. You can always rewind and look at the entire theorem. Let me just minimize so that if you want to take up a screenshot, you can anytime do that. Okay, I hope all the basic concepts and difficult questions we have covered in the video. If you still have any doubt, please feel free to mention in the comment section.